All right, so let's say you want to expand this log. And when you expand, every individual factor becomes its own log. So the first thing to do is to separate each factor. So if we take our first factor, this number 8, we can take the log base 2 of 8. Take our next factor, or our next base, x, becomes its own factor. Since x is in the numerator, it's a positive. Log base 2 of x squared. Our next factor has a base of y, so that's going to be its own log. So plus log base 2 of y. And then the final factor is a denominator. So because it's in the denominator, it becomes a negative log when we separate it. So log base 2 of z cubed. Okay, so that's the first step, just to write each individual factor as its own log. What you're then going to do is you're going to simplify what you have. So any powers inside the log become coefficients out front. So this 2 moves out front. This 3 also gets moved out front. And so you're looking at log base 2 of 8 plus 2 log base 2 of x plus log base 2 of y minus 3 log base 2 of z. And now, if this is where you end it, you haven't quite simplified it completely. Right? And what you need to be able to recognize as far as the completely part goes is anytime you see a number that can be expressed, or a perfect power that can be expressed in an exponential form other than what it is. So here you see this number 8. Is 8 a perfect power? 8 is 2 to what power? To the third. Okay, so really, if you look at it in this form, can we simplify what we had here, where log base 2 of 8, if we rewrite 8 as a base 2 exponent? Yeah, because now this power of 3 gets moved out front. And what is log base 2 of 2? Anytime you have a log where the base and the number inside the log are exactly the same, what value is that? A to what power is equal to A? Always a 1. So this whole thing right here has a value of 1. So the overall answer should be 3 plus 2 log base 2 of x plus log base 2 of y minus 3 log base 2 of z. Okay, so this would be the accurate answer, as simplified as possible.